Okay, this week we finally get talking about mid-latitude weather, where we live. So we're going to pull a lot of what we've talked about into this. So let's start by talking about air masses. Uh, Air masses form in nice, simple source regions. You think about it, a continental polar air mass. Where's it going to form? Well, once that you want it to have dry, cold air, where around us has dry, cold air. Canada. So where is it forming? Right here is the continental polar air mass taking shape over parts of Canada into Alaska. Now, what about some other air masses? We know that we have tropical ones. Tropical maritime ones, for example. And where would that be? Probably out here in the tropical Pacific, or even down here in the Gulf of Mexico, would be a tropical air mass. And they're moist, those air masses. Now, you can get an air mass develop out here in the Southwest, tropical continental, very, very dry, but still quite hot and humid. Or maybe maritime polar might come in off the North Pacific, for example, out in here. Big high pressure system out over the northern part of the Pacific Ocean, fairly cool, not as cold as continental polar, and fairly moist. So, as you can see, these different air masses have source regions. Now, they're divided, all of them, by a front. Sometimes the front's cold when we have cold air moving forward. Sometimes it's warm, like here, where warm air is moving northward. Sometimes it's stationary when it's not moving at all. But each one of these divides an air mass. So in other words, along this stationary front, we have the continental polar air mass to the north. South of it, we're kind of getting a little bit of the more tropical air mass, warmer air mass. So the whole key to looking at weather is how these air masses collide and the fronts they form and how those develop. Now, as part of a front, we develop low pressure systems. They're called extratropical low pressure systems. They're the same as any low you normally see coming across your area. So, as you can see here, right now, over Wyoming is an extratropical low pressure system. Oh yeah, guess what? There's another extratropical low pressure system off the southeast U.S. coast as well. So if you looked at extratropical systems and we looked at how they develop, we just had a question the other week about where advections are within these lows. Well, guess what? To the east of it, warm advection. The northwest, cold advection. So think about that. If a low is moving across Ohio or West Virginia, let's take it moving along the West Virginia-Ohio border up through Pittsburgh. Everything in Ohio is going to be in the cold side of that low always. If you're in the cold side of the low, what kind of precipitation you're most likely to get? Probably some snow, maybe some freezing rain even. Now, if you're on the other side of it, you're going to get more rain, and you might even have some thunderstorms. And lows come from all different positions. Here is an example of lows moving out of Colorado and up, and off the East Coast, a nor'easter. Sometimes the nor'easters even develop over Texas and move up and get very intense. And these are really areas of cyclogenesis, is where an extratropical low forms. You can see they like to develop along the Carolina, Virginia coast, sometimes down over Texas, and right on the lee side of the Rocky Mountains is another big area. With that, here you can see a typical winter storm moving up, and you can see the warm front pushing north. You might actually have snow ahead of the warm front initially, well up here, but it'll gradually, warm air is aloft, remember? So the warm air aloft gets there before the cold air does, maybe, before the warm air at the surface. So maybe you have it changing over to rain, but instead of being pure rain, it may be freezing rain before the warmer air at the surface gets there. So if you think about these, it doesn't take a lot of difference in where this low is to make a major change in your forecast. Say this low was going up to the west side of Chicago, we thought. Well, then Chicago is going to eventually wind up in the warmer air. Probably may have a little bit of snow or ice at the beginning, but quickly change over. Now, all of a sudden, a day later, we have the same low we think is now going to go to the east side. Very different forecast. They may have a tremendous amount of snow. And along the cold front, remember the cold front pushes the air up more. That's where your thunderstorms are typically at. Another thing about extratropical cyclones, they're cold. They're cold all the way up so that the thicknesses actually dip lower in them. Well, let's take a look at that in a second here. So we know we have some low pressures around right now. Right here, example is one. Here's another one. So if I was to look at a 500 millibar chart right now, well, what would you see? Notice the dip in the contours. Pretty strong dip there, which is related to this low to the east. Yes, they tilt back to the west with height. And 250 millibar, man. And here we talk about jet streams. We just talked about it. That is a very strong jet stream coming down on the west coast right there. Think about all the energy and oomph that's pushing south there. And here's another, it's more like a subtropical jet coming in across the southern United States. And there's one off the east coast. At 850 millibars, we can actually see a little bit of that low that we were talking about over Wyoming, a little bit to the northwest of it. But you can see some warm advection coming on the east side of it and some cold advection coming back here. And when we look at this in satellite, you can actually see the low wrapping up right in here. And that warm front we had, look at the thunderstorms that are popping up in here. And the low off the east coast, there it is, and pushing clouds back into the northwest. They're actually at my house right now. So one of the interesting things is you can look at the radar and actually see the corresponding precipitation patterns with each of these lows. Look at all the convection, more warmer water down here. There's a lot of thunderstorm activity going off the east coast right now. And with all of that, what if you have warm core cyclone? These happen a lot in the summertime, and they happen over areas that get very, very hot. Desert Southwest, classic example. Well, remember, with a warm core cyclone, the low pressure at the surface is caused by that warm air. But as you're going up, because it's very warm, the pressure is not going to drop as fast. You wind up with a high pressure, literally a ridge of high pressure over the low. Whereas with a cold core extratropical storm, you have a low pressure over the low. Another circulation that's talked about here in the mid-latitudes, and we have these as sea breezes. We've discussed them a lot in the last several weeks. And we even I even brought up in the weather blog about the one that just occurred. Well, that was a lake breeze, we'll call it. But these are much smaller scale along the coast. I'm sorry. And here's our mountain breezes. What happens in the mountain, you think about it, the sun's not getting everywhere equally. So maybe you're down here in the valley and you don't see the sunshine till almost noon because the sun can't get to you. Well, it's heated up this mountain though. So what it does, that cooler air down here stays here, but that mountain's got warmer. So it has convection that goes up and then pushes the air down over the valley. So you wind up with some clouds maybe on either side, but not in the middle. At nighttime, on the other hand, we talked about radiational cooling. Flows down the mountain, so the coolest spots are always going to be at the bottom of the hill. And these mountain breezes can be brings like Chinook, which occurs out in the western United States a lot. And when it comes down the mountain into Los Angeles or San Diego, it's coming off fairly high, 8 to 10,000 foot mountains here. The wind's coming down to sea level, If it compressed that much, think about it. Temperature warms at 9.8 degrees Celsius. The moisture in the air, it's got no moisture that it's gaining. So where you had to have clouds here, an 8,000 foot drop is about 3,000 meters. So you probably have warmed almost 30 degrees. So maybe you started out at 40 or 50. By the time you got down here, you're 80 or more. No more moisture. So all of a sudden, you got lots of dryness here. That's why you're getting so much potential for forest fires in that area at that time. So one of the other things with all this is we got to forecast where these front point, and then from that, how the extra tropical lows are going to move. And this is just a one-day forecast. You can see the low that we looked at off the coast down there has made it up just to the east. My house, moving up slowly, might cause me a few showers. The low out west is getting stronger, more intense. And we can see a new low is forming down here along the front now. And it even has some pretty good rainfall coming in here. Some heavy rain, possibly a flash flooding in this area. Oh yeah, you can see the snow in the mountains here now. The mountains are getting cold enough that we're starting to get some snowfall in there. So this is just a picture of what everything we've learned, encapsulating it in just to looking at the mid-latitude. So I hope you got something out of that. And let me know if you have any questions.